I want to show you how to create the fracturing and use the cluster inside the Voronoi node. And also I start to introduce you on the using the constraint, in particular the glue constraint. Okay, we can start with a new node. In new node we can geometry node. And I can delete the file, I can create the sphere. And inside the sphere I can change the radius. And the primitive is a polygon, and the frequency I can assign 8.6. Okay, it's not very much. And also I can create this transform node, and I can move up. And I can use the ISO offset, scatter point, and the Voronoi fracture. Can connect this here and this here. Maybe we can use not much more. Inside our fracture noise, I can use visualize the pieces. And attribute, I can delete the attribute, I can create the assemble. And inside the assemble, create the pack geometry. Now I can create the null object. The null is out sphere fracture. Change the color with our customer color. I create the red because red is immediately you can see in every position you can attract your attention. The red color is very good for this. You can use also the green or another color, but this is more customized situation. How do you want to create our node? Also, I create another node called the grid node. And in the grid node, for now I can choose, for example, I can select the points from this toolbar. I can choose points, can take these points and move up. And rotate, if you rotate. If I want to change the position of my axis, I can choose, for example, with the right mouse button, align a handle. I can use the object, the world, the view or component, or press M from the keyboard. If I choose the world, the axis is on the world, so I can move it here and rotate a few. Okay, and I see also when I selected the element like the vertex, like the edge or the polygon, and move it, I see immediately Houdini added the node called edit. Okay, this is very important. Also, I can come back if I want to change something. I can come back here and change, and then I see the my edit is working again. Okay, this is the powerful of Houdini is also this. However, now I can create another null object, and I call out grid. And assign also the color, the dark red. In the previous videos I show you how to create our DOP network using the shelf, and with the shelf is create automatically the AutoDOP network. But I can use also the network inside the node of the geometry, so without create the automatic but create with custom. For do that, I can press the tab and choose the DOP network. The DOP network is the dynamic network, and here inside I can create all kind of dynamic, like the rigid body simulation, like the particles, and the pyro, or for example the fluid simulation. Is not only for rigid body simulation, but in this case I want to use only for our fracturing simulation. So I can also call this my DOP RBD simulation if you want. Okay, inside this I can go to create my layout, and for my layout I need to create some node like the pack RBD pack object. This is my object for connect to my sphere. So, and I create the RBD object. This is my grid, and I need the merge node, so I can connect, and I need the solver. The solver, I can use the rigid body solver. This solver is the free engine inside only one. Okay, I have the solver engine is bullet, is the other, or is RBD. RBD is native from Houdini, is very good, is very slow, and for this I prefer use the bullet system. Bullet system have another kind of problem, but is very fast respect their RBD. Okay, in alternative of this node I can use the bullet solver. It's the same solver you can find. It's the same solver you can find inside the rigid body solver node. Is the same engine, but the difference is very only this solver. Okay, you don't have more choose for another solver. For this I prefer use this solver, so it's very fast to create for use it. Then I use the gravity node, so the gravity force, and connect to our out. By default, every node like the RBD packet and RBD object use the sphere inside our viewport. So for connect the pack object I need to choose the path, our geometry. I can use also the relative path or the universal path. What's the difference? Universal is go to our, I can click here to select and can go to search. Okay, here in my sphere fracture, and I use this and accept, and I see I have the slash object, the geometry, and the output node. Okay, this is all more long. Okay, in relative is a few difference, because I can use the relative is, for example, dot dot slash dot dot slash, and I can go to take out grid. What's the difference? What's the big difference from this to this? The difference is if I move this my node, the rock node in another geometry, in another node of geometry, he looking for another node is called with this name. Okay, is the relative about of this node inside another kind of node. What I mean? A little example. If I create another node, geometry node, and inside I create a grid, or better, I create the null object, and I call with the same name of our grid. Okay, here I have this null object. I can hide the other object from another network, from another level. Okay, I go here and I copy my RBD simulation and paste inside this node. If I paste here, I go inside. This is find the path and find our node, so I see my geometry. Here I don't find my node, so he don't find nothing. Also I have the same node is called outGrid, but he don't find a relative. Okay, if I press again dot dot slash dot dot slash, and I can find output grid. He find now, but he don't see nothing. Okay, if I, for example, create the sphere or the tube, it's very different geometry, but I connect to my grid and jump here, and he find, and he find. Automatically is attached to the node with called in the same way from another geometry. Okay, the same if, for example, I find another name and he find. Okay, back, I can delete this network, is not important, and this I can call our fracture. Go jump inside, and now I can jump inside our simulation. Another point, more important, is how the RBD interprets our geometry. Here I have the fracture noise. The fracture, if I go to the bullet, and also I can show the smooth. Okay, if I go inside here, I find in the bullet, I find the convex hull. I can change display geometry and show guide geometry. The guide geometry is the geometry how is Houdini interprets my fracture. Is convex hull, concave box is take all geometry and consider the box, capsule, the cylinder, and etc. Convex hull is maybe the good and faster to calculate. Concave is a bit slow and sometimes can create a little problem for our geometry. But for now we can assign the concave. The same is for our plane, but I can go inside here, go to bullets, show the grid, and also if I choose the concave, okay, now I can see the concave. Another aspect more important for our simulation, if I go and press play on our simulation, I see also my plane is go down. I want my plane is go down, so I can create from the RBD, create active object, but use the object transformation. Use object transformation is good for all. If I press play, I can see now it's stopped. Okay, I can stop my simulation and go back, and I see it's working very fine. Okay, here let's go down, it's working without big problem because the interpretation is very good. But sometimes again, don't show a grid, show the display, our display geometry. Okay. Sometimes this interpretation on concave is not very good because maybe our plane, in more case, we can interpret it by the convex, okay, like convex. So my geometry it don't take this and it's not working very fine. For fix it, we can come back and we can create inside our network of the path of the grid, we can create the extrude volume, for example, and the extrude volume is create the volume from the top to the Z to 0, from create the full solid, okay, and then I can use the Voronoi fracture and the scatter and the ISO. Can connect the ISO to scatter, create this. In this way I am sure my simulation is working very fine because I create the more points. I am sure this part is working without big problem. Another alternative, we can use the VDB convert for create the geometry for create our part. For example, VDB from polygon is very nice tools. Why? And what he do? This creates a voxel with the square from the sides. Like part 1, I can see 1, the big square, create a big square. In part 2, it's very big. Create like the proxy, and very small. It's very accurate and is very fast for our simulation. In some case, it's very good for create, for example, the proxy for our geometry when geometry is very complex, but it's not working every time because our geometry needs to close in every vertex. In this case, it's not important to use the Voronoi from polygons because it's not complex geometry, but this is, for example, the alternative to another situation. However, we can go to our auto grid can go here. Okay. Jump inside, and from our bullet we can create the concave. So the concave, if you slow, but is working very fine. We can also hide. Can smooth. Press play for see the simulation. And now it's working without problem. Okay, this is another way for create the simulation. I can also create, we can real time, okay. I can also create another geometry for create the interaction with our simulation. Foresee another way to connect our geometry to my layout here. For example, I create tube. Change radius, change the position, and rotate it. Oops. No, don't want. Okay, we can create the transform node. Maybe it's more faster. And also I can handicap. And we can rotate it and move it here. We can switch to the top view. Okay, it's working now. And here I can change, for example, from polygon and assign a few polygons. And inside here, can switch perspective. I can use the static object, and I call my object from the SOP, and I can use the merge node and connect it here, and the bullet it here. Maybe I can put a few down. Okay. And now we can see how it's working. By theory, our static object find our system and is create the interaction. But it's not correct. Why is not correct? Why my fragment don't detect the collision with my tube? Because I use the merge node. In the merge node, I don't have the good system for interpretate it. What I mean? Here I have the affect relationship left input after on the right So left input in this case is my bullet, affect on the right on this, so not have the my previous, like the static, find interaction with my bullet. So I can choose, for example, the mutual. Mutual is create the interaction with don't consider the left and the right. Or I can switch, for example, the static and say to Houdini, find the static object when find the bullet is going the interaction and create the interaction between these two elements. You can come back, press play, you can see what's happened. Now I have the interaction with the element. Okay, this is another way for create our simulation inside Houdini with the rigid body. Now we see how to create the cluster, because I have our fracturing, and when it's collapse and go to interaction with my rigid body simulation, with my rigid element, is fracturing in all part without create some part to be very big or small. For fracturing, for create the clustering from fracturing, I can come back, and from the Voronoi fracture I can inside, in the option inside, I find the cluster. The cluster is very easy to create. I can cluster the cluster piece, and can, for example, okay, the cluster piece, I can create the add, and now I can see what's happened when I go down here. Okay, see here the cluster is created. It's created a very different kind of cluster, and inside the option I have the sides. I can change the sides of my cluster. I can reduce for create a little cluster or the big cluster. From the various axis. Okay, I can enter Gillette, I can enter the offset, I can enter random detached part very randomly, and I create the constraint network, but this is not good for me now. I can also delete the stereo cluster. What I mean, not in this case, but if I use, for example, the Voronoi fracture points, and I want to remember you, the Voronoi fracture points is another way for create the distribution of my cluster. Okay, I can connect this here, my geometry. I can connect the scatter, another scatter, okay, can, for example, move this here, make more room. Okay, from the scatter I choose only 2 points. Okay, points, and I can reduce the radius and connect to my fracture point. Use also the switch switch node is very interesting node because I can create some setting and I can choose, for example, from this with the full line and with the dash line. Dash line is the input number 2. I can, in this case, the input number 0 is the Voronoi fracture points node, and the dash is only the scatter. So I can choose, for example, I can switch from the Voronoi to the scatter. This is very interesting node because maybe sometimes you try to create one setting, you think, oh my god, this setting is good, but I won't try with another setting. And when you try with another setting, maybe you work for more time, you delete the node, you don't find the way for comeback, and you can create, for example, the switch node, and so you can compare more faster the two way to use it, or this or this. Oh, it's very cool this. Okay, and now I use this. I'm sure, yes, I can delete the old way, for example. And I use this for this or for switch, for example, for alternative. In this case, I can use this for this situation. You can see now with delete the cluster, stereo cluster, and you can see the cluster now is created only on where is my Voronoi fracture points, only on this point. Okay, this is very good, and we can see also how to use this way in the difference to another way. All the way with the cluster with the ISO, the scatter, and blah blah blah. And now we can see what's happened when I simulate this. Okay, I see my cluster is create a very big part, and with some is don't fracturing. Okay, what's happened when I have the cluster with the Voronoi fracture points with only 2 points, so it's not all part, we can switch to 0. So I have the cluster only here, and only this part is broken, and also this broken, and this is not broken. And for example, I can yes, oh yes, it's okay. You can see now in our simulation. Okay, I can come back a few frames, and we can see the little problem with my geometry. The problem is the compenetration of my piece inside another geometry. And this is happened because my convex is not calculated very good. It's not calculate the convex and don't calculate the concave. You can fix it with another node, another kind of node inside Houdini. But before, I prefer to save it, and you can see how to fix this problem. Okay, for fix this problem, I need, for example, to make room to create a node for unpack or for separate, for example, this part to this part. Here I have the create name attribute, and I have the piece Okay, I can call fragment like the preface. Okay, split the top to the bottom. Okay, and here I want the geometry space sheet is here. Okay, I put here. Here I have the fragment. The fragment is 0, 1, 2, 3, etc., etc. Okay, and here. Now I have the fragment. Here I have the fragment. Okay, I can create the delete node. Connect the delete node. We can name unpack, maybe. Can unpack the geometry. Okay, we can create the unpack the geometry, and we can choose, for example, fragment, name fragment 0. Okay, so I can delete not selected, and I can come back here, delete selected. So I have two now, our two geometry. One is the geometry for the fragment, and here is the geometry for the rest part of my fragment, and I call this passive fragment, and here my active fragment. Okay, now inside the active fragment I create the for each node, for each subnet node, and I can also create before the unpack for my security, but is a okay is warning because I apply the unpack here, so it's not work. Okay, it's not necessary of this. And then I create I see. But we start with the passive. The passive, I need to create the part for fix the convex. How the situation of my grid, I can use another Voronoi fracture and use the ISO. Use the scatter, connect the scatter to Voronoi. Okay, now it's working. And create the pack object with the pack. Then I can create the null object, and I call out fragment, passive fragment. Right. Okay. I can come back this for gray, light gray, or maybe with pink. It's not okay. This is red. And inside my DOP simulation, I create another rigid body and I choose my passive rigid body and connect this here. This is my my grid. I can connect also my grid from this node because it's the static, it's not dynamic. I can disconnect this here and here I can put up. Okay, now it's working very well. And from here, from the active, I can use the for each. For each is the subnetwork because inside I have another situation where I can create another node. And sometimes when you create this, the layout here is take only one node and create the array for all nodes or for all element inside my node. Okay, so I can use, for example, the each by attribute, and the name of attribute I can call name by name, and inside I created the name and I created the transform node. Inside the transform node I can see now I see only one node, one part, okay? And inside my transform node I can use the pivot for center the pivot inside my object. For do that I need to create a little expression. The expression is called Centroid Expression. For do that I can select my pivot, my x, y, and z, and for my x a dollar, for a sign CA the centroid by x. Okay, in this way is center my axis from my object, the 0 0 of my object, the 0 from the x is the center. I can do the same with the another axis, dollar $CA Y, dollar $CA Z, and I see also now viewport my axis is centroid on my element. Create another node is a back node. So I am sure is packet, okay, and this is a node is create for every part of my geometry, okay, my fragments. Now I create another node, the null node. I can change the color and I call out active fragments. Now here I have this and this, okay. Now inside my DOP network I can choose here it's my fragment, and here I can choose my active fragment. Now we can see what's happened when I start my simulation. I can check also the convex and the concave. concave for my shoulder width. I create the active geometry. See, now it's working. Also, if I can create the concaves. So, turn off. In alternative to concave, because concave is not very fast, I can use also the create convex tool to preset soft selection, but for now we can see with concave for fix. Maybe is the good way. Also we can see that, yep, maybe it's working fine. Yes, it's working fine with that. Now we can create our simulation. Can press play, but okay. Display geometry. Okay. Can see what's happened. Can come back here. We can see my simulation is not have any kind of penetration, the object inside the object, and is working very fine. It's working very well. Okay, and this is the cluster. Okay, the cluster is very big. You can also see how to don't create the cluster. What's happening if I don't create the cluster? Obviously I have some part now is not working because he don't have the setting correct for delete, not delete. But if I don't create the cluster, is working very fine, like before. Okay, so however, in cluster, another aspect very interesting from the cluster is create the interior details. Interior details can create the explode view. Explode view is the tools for analyze my geometry. Okay, for analyze my element when is fracturing. I can come back to smooth and white shade. Inside my Voronoi fracture, I have the interior details. Interior details is used for create, for example, the displacement, for create the more details inside my geometry. You can see you can create the detail sides, more is small and more details have inside. It's not very, but it's very huge to control. Okay, the amplitude is how much is go up and down. I can use that kind of node inside my frequency and the turbulence. This is the same value you can find in the map of noise. Okay, we can see also another way for create this. Also I can use the ramp, the noise ramp. is very nice tools because I can create a very different curve and check, control my noise by the curve. Okay. Also I can see the same inside my part when it is destroyed. Okay. And I can use also for my simulation, for my Voronoi, for the cluster, I can use also the constraint for connect this and for don't create some kind of more destroy and create some values of destroys the interaction with destroy. Okay, we can see with another example. I can go up, I can unhide my fracture, and I can create another geometry node and go inside, create very fast the box. I can delete the file node, and inside the box I can create another Voronoi or transform can scale this if you better, for example, to move up and rotate. But before rotate I want to destroy. For destroy I can use always the Voronoi fracture, and I can use the ISO and the scatter. But I can use this node usually because it's very good for create our simulation, but it's not the only node we can work with the fracture point. I can use, for example, the grid node also, and I can attach my grid nodes to my Voronoi fracture. And when I see how it's working, is create the fracturing. If I change, for example, the sides, I can see my sides is working. I can rotate, I can apply, for example, the transform node. And I can rotate, and I see it's working again. What's the big difference? The big difference is this is the projection from the top to my geometry, and I see here is not working very well. This is the projection, okay? It's not to create a variation inside here, but I can, for example, create variation on also on this node. Okay, for example, I can create a scatter point. Can find my scatter point. Okay, here, and I see here I have the more variation. Okay. And create but the solid here, not have only variation on this line, but have the variation on my points. Okay, maybe it's good because now I can see what's happened if I, for example, create a switch, this to this, this to this, okay. This is with the plane, and this is without the plane, with the scatter point, and here I have the variation, okay, on my side. Maybe it's can be good for some reason, or for example I can use also the sphere. I can change my sphere here. I can use the scatter for my sphere. See what's happening if I switch with the sphere. Oh, I have some variation here. It's nice. It's nice situation. Okay, we can try with this. Okay. Also, I can use the ISO software, ISO offset inside my sphere, and maybe I can assign a better radius sample and see what's happening. Bypass it. Maybe it's better without the ISO. Okay, now I have this, and here also create the symbol. Inside the symbol, create the name, the null, now I create my DOP network. Inside the DOP network, I create the pack, a BD pack object. I create the bullet solver, and I create the gravity node. And also I create the ground plane with the merge. Net this to this, and this is out. Okay, if I press play, I need to assign, can choose outer box, and we can move it. So it's more interesting simulation. If I press play, I see my simulation is working. Okay, it's working, and is go all part is bounced. But maybe we can use more scatter points. More interesting simulation. Okay. Or better, I can create another node, the sphere node, the tube node, and the cap, Okay. Polygon. Can create the Rigidbody simulation. I can create the RBD object. I can create the merge node. And here I choose my tube and use the active. Okay. Okay, I can see what's happened. Now, if I press play, okay, it's broken. Now it's broken and go in more direction. I want to create the glue system. The constraint is like, for example, this part is connected with another part and is very difficult to broken it. And for do that, I can go to my shelf. I prefer do that with my shelf because it's very fast when I create it by shelf. For example, I have here the glue adjacents. Okay, I can say now selected RBD object to glue together, press enter to complete. So I can select my fracture system and press enter. And now is building automatically a system like the RBD object is the constraint network. With the constraint network have the solver, the SOP solver, and inside I have the glue constraint. Also, automatically in object level, Houdini create the glue RBD packet object. Okay, inside here I find more node for creating my system. What this system do? If I press play, I see I don't create the cluster. I don't create any kind of connection by the cluster. I create the connection only by the glue. From the points is create the network, and okay, is create the network from the points of my fragments and create more glue system. So if more strong, the part is not broken. So if I go inside here, go inside my dot network, and I see if I change the glue constraint, the strange is the power of my system is connected. If I give more high value, is not broken. Okay, is very hard to broken because the strange is very high. But if I give more or less, like -1, it's the same. -1 is not broken. Okay, for sure I can delete the simulation, set simulation. Okay, if I say for example 10 is broken like, or maybe is very similar to without have the glue constraint, and see some part is have the constraint. Also I can see my network. I can give, for example, I can see it's working. Half-life is the impulse half-life. is the value is from my part is broken in the time. The propagate rate is the time for how is decadency of my system. But another part very important is the network of the point for my glue constraint. If I go in my node glue RBD packed object, here I find the fetch object, and here I find the connect advantage piece. Okay, this is the points for area, is the network of my kind of my system. For example, if I do more, is connected to max point. So if I give more here, also here, you see I have more points to area. Now I have points. I can go up and go down and give more points for area. Also, I can choose, for example, the part of the surface point or only the points. Okay, I can use the piece. The part of the piece is connected. You can see the difference now. What's happened with the piece? Maybe okay. Select this. Maybe we can jump here, and give 1000. Here, if I give the advantage point, you can see the difference. It's more similar. You can see what's the surface and the points. It's moving also the surface and the points. Also, I can use this system for create the static object, and he work when is hit to another object. What I mean? I can create another system, for example. Sometimes Houdini have the problem to the viewport. We can create another panel. We see that it's working now. Okay, it's a strange situation. We can create another geometry node, add inside, and can create the box. Can create the sphere. Can create the Voronoi fracture, eyes offset, scatter, or maybe better we can create, yes, scatter. Voronoi fracture points. We can create the transform node before. Let's do this. Scale 3. The center is 0.25. 5. Okay. Sign 6. So it's 3. Okay. 2.25. 5. Strange. However, okay. Okay. Go up. If you go up, neutral. Okay. However, we can create one, and we can create a seed. Okay, I want here. Okay, and now symbol. Create the null object. And now I create the sphere. The sphere is here. Change the radius, change the primitive, move up. Okay. You can change the radius to okay. Null object. Now we can create dot network. Side dot network, create RBD packed object and assign my tower, my RBD object, and assign my it ball, the merge node, bullet solver, gravity node, RBD object the ground. Can create another ground and the merge node. Then I can select this and connecting automatically is create the correct connection. Okay, if I press play, I have this. Now on my object I can set the initial state, the velocity. I have here the axis, the z-axis is positive in this direction, negative in this direction. So x, y, z, I can assign the velocity z to 10, for example, very big. Press play and I see, okay, it's arrive and hit my geometry and destroy, okay? But I see my tower is go down and start to destroy before, okay? Now I can create the glow system. And inside my glow system here, spot, example 5000. You can see now is oops 2000. 5000. Oh, it's art. You can see, okay. Also, we can go up on my transformation node from the front view. My transformation node, I can go down use okay. I can jump inside here, perspective. Now we can see okay, this is the little example. We can also create another kind of constraint for create the connection here and for create the best simulation. Okay, so but you can see with the glow constraint you can create the good system for static object. Okay. Okay, now I want to show you another kind of constraint you can use inside Houdini, and for this I create one example file. I jump inside. It's very basic with a shoebox and two nulls, and inside I have my DOP network. Inside my DOP network I have two Rigidbody node object. One is active and one is the static. Static is this box and active is another box. I have the Rigidbody simulation with the bullet and the merge node with my ground plane for have the interaction of my ground plane with my simulation, and the gravity node. Here I have more kind of constraint. I have, for example, the pin constraint. Pin constraint is very interesting because when you, for example, create pin Rigidbody pin constraint, we can connect it, and here I can choose my constraint object is the active and the goal object is the static. And I see now here, I pass in wireframe, see here I have the connection between this element by one goal node, okay, with the join node. I can, for example, also take the manipulator and, take the manipulator and move this object. And when I move this object, I choose how it's work at this point. For example, I can put here, or put in the corner, or put, for example, here. If I put here, for example, you can see what's happening if I put here and connect this point, this node to my out. And we can see, come back to the shaded, press play. You see my point is here, okay, but is the connection, but is the point is here, so it's moved by where is my join, okay. But I can create more situation with, for example, I here have one node, one connection, and here I have another connection, so I use the merge node, and I find I can delete this node for now. Okay, and here I find that two node is connected, and when I press play for see my simulation, I have this effect. Okay, it's very nice, it's very fast to use it. Another kind of constraint is the spring constraint. You can see here, pass to one. Spring constraint is have the different kind of setting. For example, by default, in the spring constraint, come back here. Also here I have the 1 point with the connection by the middle, okay, point, and by default, if I press play for my simulation, I see effect of my spring is go around. But you can, for example, use the damping effect. We can see with damping effect is very crazy now because the simulation is not setting very well for this kind, but we can pass to 2 with the damping. Okay, you see it's continued to damping to the stretch to the spring. Okay. Another effect is with the limit by force. The limit by force, you can set in here the limit. We can enable the limit, and we see when the limit is arrived. Oops. Okay. When the limit is arrived, is my connection, the limit in this case, this element, okay, is 100. When is arrived to 100, to that damping is 100, so when arrived to find this limit, is broken my element, so is go down, is broken the connection between these two elements. You can control the connection with the two elements and also with the broken this effect with the length. The length, it's with the limit, the length. In this case, I have this limit, but if, for example, if I put 0.5, and I pass to number 4, is the limit of my geometry where it's broken. If 0.5, you see the connection is not broken, but if, for example, press stop and come back to 1 or to 2, 0.2, for example, you can see, okay, it's not broken, but if I change to 0.1, we can see when I arrive to 0.1 is broken and is go down. Okay, this is very nice effect you can use. Also, in this case, you can move it for change the position of his go around, for example, in the corner, for example, out the corner, go down the corner. In this case, it's not broken again. Okay, you can find the good position for your effect. Another kind of constraint here is the Rigidbody angular spring constraint. This is nice because you can use this for create also the angular effect of your situation. And here you can control by the torque, by the rotation, by the strength, and by the depth. For example, you can see here, I can put this here, okay, and I have also the control of my rotation, okay. If I press play, okay, it's very crazy now because it's go around, but this is the effect you can have, okay. And also here I have the angular spring constraint, but I can check also with another kind of with the bullet angular constraint. And so this is the kind of the constraint you can use. Obviously, the most popular and most used constraint inside Houdini is the glue constraint. It's very nice to use it for create the effect like the previous file I show, for example, for the previous file, for example, for see the effect of destruction. It's very nice and very comfortable to use it.